When laser optics operate under intense laser irradiation, they might eventually suffer from damage. The damaged optical element doesn't work as expected and cause multiple troubles in various laser-based systems. In order to avoid unexpected laser damage, optical elements should be tested before use. How to survive laser damage? There's several possible methods, and R-on-1 test is one of them. The R-on-1 test is probably the simplest and often the only way to find a preliminary laser-induced damage threshold for testing area-limited or curved optical elements. Let's discuss how the R-on-1 test is conducted. Firstly, the sample surface is divided into a virtual matrix of test sites. Each test site is visually inspected under a microscope prior to laser exposure. Next, the sample is placed in the path of a focused laser beam. The incident laser power is usually monitored by the power meter. The first test site is now exposed by a burst of weak laser pulses and then inspected with the microscope again. The status of the irradiated site is identified as either survived or damaged. If no damage is found, the intensity of the laser pulse is then increased and test site is exposed again. The ramping of the laser irradiation level continues by increasing laser power in either a linear or non-linear way. The interrogation process continues on the same test site until the material is damaged. The damaging laser irradiation can be considered as a preliminary damage threshold of material. In practice, multiple test sites are interrogated. Due to the statistical nature of the laser damage phenomenon, different tested sites can be damaged at different fluencies, even though the ramping remains the same. Thus, the more sites are tested, the better. Laser-induced damage threshold is defined as the lowest fluence among multiple test sites. The R-on-1 procedure is a subject of several important risks. Firstly, it is not suited for samples with low defect density. Secondly, due to possible laser conditioning, the R-on-1 LIDT can be significantly overestimated. Thus, measured values should be interpreted with great care and only used as a rough LIDT estimates. Thirdly, the fatigue, incubation effects are not considered in the test. And finally, it is worth mentioning that this testing is usually very time-consuming. R-on-1 test cannot give precise laser damage threshold, as laser ramping might cause conditioning or fatigue effects. Thus, this procedure is only recommended to test for limited aperture samples, when other test procedures are practically unavailable. Otherwise, it can be used to study the conditioning effect, usually in combination with one-on-one LIDT test procedure. Contact Lidaris to learn more about R-on-1 test and other ways to solve your laser damage problems.